Recently, humanity reached a silent milestone, an event that should have been celebrated with fireworks, parades, and magazine covers, but that, if you look closely, is actually a reason for deep existential despair. Voyager 1, the most complex, fastest, and most distant machine ever built by human hands, has just crossed an invisible line in the cosmos. Launched in 1977, it has been traveling through the void for almost half a century. It is moving at a staggering speed of 61,000 kilometers per hour, fast enough to cross a continent in minutes. And after 48 years running at maximum speed, without braking, without stopping, Voyager 1 has finally reached the distance of one light day from Earth. One light day. NASA celebrates this as an engineering victory, and it is. But for anyone who dreams of exploring the stars, that number should sound like a life sentence. Think with me. It took nearly 50 years of maximum effort, using the best technology of the 20th century, taking advantage of gravitational slingshots from Jupiter and Saturn, just to move away by the equivalent of a single day on the scale of the universe. If it takes us 50 years to travel one light day, how long do you think it would take to travel one light year? And remember, the nearest star is not one light year away. It is 4. Science fiction lied to you. It made you believe that space is an open ocean waiting for brave ships. But today, we are going to look at the cold, cruel math of reality. We will discover that the solar system is not a port from which we can depart. It is an island surrounded by an abyss so vast that the human mind refuses to comprehend it. Prepare to recalibrate your sense of distance. Because the truth is that Voyager 1 is not going anywhere. It is just a metal monument floating motionless at the door of our cell. The biggest problem with our cosmic perception is language. We use terms we do not understand. We say light year with the same casualness that we say kilometer or mile. We hear on the news, astronomers discover habitable planet 100 light years away. And our brain, accustomed to airplanes and cars, thinks, that is far, but if we go fast enough, we will get there. The term light year is a psychological trap. Because it contains the word year, we associate it with time, with something traversable. But a light year is not time. It is a measure of distance so obscene that it becomes abstract. 1 light year equals approximately 9.4 trillion kilometers. 9 trillion. Numbers that large mean nothing to us. The human brain shuts down past 1 million. So let us visualize this. Let us shrink the universe to fit inside your living room. Imagine that Earth is a tennis ball. On that scale, the moon would be a marble about 2.5 meters away. You could take 3 steps and go from Earth to the moon. The sun would be a giant sphere, almost a kilometer away. Now where would Voyager 1 be, our most distant ambassador, which has traveled for 50 years? On this scale, it would be just a few kilometers from the starting point, maybe in the neighboring district. And the nearest star, Proxima Centauri, where would it be on this scale where Earth is a tennis ball? It would be 260,000 kilometers away. If the tennis ball Earth were in New York, the neighboring star would not be in California. It would be almost at the real moon. There is an absolute, black, deadly void between our tennis ball and the next relevant object. There are no gas stations. There are no islands. There is nothing, just vacuum, radiation, and cold dust. And we look at this abyss and think we can cross it because we built rockets that go to the moon in 3 days. It is like an ant climbing onto a leaf floating in a puddle and thinking it is ready to cross the Pacific Ocean. The light year is not a ruler. It is a wall. Let us go back to Voyager 1. It is our best example because it is real. It is not a theoretical warp drive. It is not movie magic. It is metal, circuits, and real propulsion. Voyager reached 1 light day in about 48 years. A year has 365 days. The math is simple and terrifying. Multiply 48 by 365. For Voyager 1 to travel the distance of a single light year, it will need to travel for approximately 17,500 years. Let that number settle in your mind for a second. 17,500 years. That is not travel time. That is geological time. That is evolutionary time. To put it in perspective, 17,000 years ago, human beings were still nomadic hunter-gatherers. The Ice Age was still ending. Mammoths were still walking across Siberia. Agriculture had not been invented. The first cities of Mesopotamia were still 10 millennia away from being founded. There was no writing, no wheel, no metallurgy. If, at the height of the last Ice Age, a tribe of humans had launched a caveman Voyager into space at 61,000 kilometers per hour, that ship would be completing 1 light year today. And guess what? It would still be in the middle of nowhere, because the nearest star, the Alpha Centauri system, is not 1 light year away. It is 4.2 light years away. So take your 17,500 years and multiply by 4. Add a little more for the fraction. We arrive at 74,000 years. 74,000 years to reach the nearest neighbor. Modern humanity, Homo sapiens with complex cognitive capacity, is about 200 or 300,000 years old. A one-way trip to the nearest star would consume a third of the entire history of our biological species. This destroys any concept of exploration. No machine built by humans lasts 70,000 years. No battery lasts 70,000 years. No hard drive retains data for 70,000 years. Metal cold welds in a vacuum. Cosmic radiation destroys circuits. If we launched Voyager toward Alpha Centauri, which it is not doing, by the way, it is heading toward nothing. It would arrive there as a piece of inert, mute, unrecognizable space junk. And if there were humans on board, the situation shifts from an engineering problem to biological horror. But we can build bigger ships, say the optimists. Generation ships. Floating cities where people are born, live, and die, passing the mission on to their children until they arrive. This is a beautiful idea on paper. In practice, it is the setting of a sociological nightmare. Imagine locking a population of, say, 5,000 people inside a metal can. They have to survive in there for 70,000 years. Empires on Earth, with all the space and resources in the world, rarely last more than 500 years. Languages change to the point of becoming unintelligible every 1,000 years. Religions are born and die. Cultures collapse. Inside the ship, in just a few generations, the mission would be forgotten. The great-grandchildren of the original crew would not know what Earth is. For them, the universe would be nothing more than the metal corridors of the ship. The outside would be a deadly myth. In 10,000 years, the language spoken on the ship would be completely different from any language on Earth. In 20,000 years, genetic mutations caused by radiation and isolation, inbreeding, would begin to create a new human subspecies. In 50,000 years, it is likely that civil wars over limited resources would have already exterminated the population or destroyed the life support systems. And if, by an absurd statistical miracle, they arrived alive at Proxima Centauri after 74,000 years, they would no longer be human. They would be creatures adapted to artificial life, pale, fragile, insane by Earth standards. They would arrive at their destination without knowing why they went, and if they tried to communicate with Earth, the reply would take 4 years to go and 4 to come back. But who would be on Earth to respond? In 74,000 years, the civilization that launched the ship would likely have disappeared, gone extinct, or evolved into something that no longer cares about the project. The generation ship is not a ship of exploration. It is a time capsule full of corpses and ghosts, launched into the dark without purpose. I know what you are thinking now. You are using Voyager's speed. Voyager is 1970s technology. In the future, we will have fusion engines, antimatter, lasers. Let us be optimistic. Let us be incredibly, irresponsibly optimistic. Let us say that in the next century, humanity undergoes an unprecedented technological revolution. We master nuclear fusion. We build antimatter engines. We manage to accelerate a ship to 10% of the speed of light. 10% of the speed of light is 108 million kilometers per hour. It is a speed so absurd that a grain of dust hitting the ship would have the force of an atomic bomb. But let us say we solve that with magical shields. At 10% of the speed of light, how long does it take to travel 1 light year? 10 years. Okay, that sounds better. And to reach Proxima Centauri? 42 years. 42 years of travel, one way. Add a few years to decelerate. Add exploration time. Add the return. We are talking about a mission of 90 to 100 years. Even with divine technology, traveling at speeds that border on the impossible, a trip to the nearest star still consumes an entire human lifetime. An astronaut would leave Earth at 20 years old, say goodbye to everything they know, spend 40 years locked in the dark, arrive at the star at 60 years old, look out the window for a week, and spend the rest of their life trying to return, dying of old age along the way. And that is for the neighboring star, the closest of all. If we want to go anywhere interesting, like the TRAPPIST-1 star, which has Earth-like planets, it is 40 light years away. At 10% of the speed of light, that would be 400 years of travel. We return to the generation problem. We return to the problem that human biology was not made for these scales. We are not a few technical adjustments away from conquering the galaxy. We are limited by the laws of physics. The energy required to accelerate anything to 10% of the speed of light is greater than all the energy humanity produces in a year. We are turtles dreaming of being eagles, but the shell is too heavy. But the story gets worse. Remember when I said Voyager left the solar system? That is technically true for the heliosphere, the bubble of solar wind. But gravitationally, no. The true wall of our solar system is the Oort Cloud, a gigantic field of comets and ice that orbits the sun. The Oort Cloud begins at an immense distance and ends almost a light year away. This means that the sun's territory, our home, extends for almost 1 light year. Remember the math? 17,500 years. Voyager 1 will take 300 years just to reach the inner edge of the Oort Cloud, and it will take 30,000 years to cross it. For the next 300 centuries, Voyager 1 will not be in true interstellar space. It will still be in the sun's backyard. It will still be subject to our star's gravity. We never left home. We barely reached the mailbox at the end of the street, and we are already tired, old, and out of energy. This forces us to confront a truth we avoid at all costs: the Fermi paradox. Where is everybody? Maybe the answer is simple and depressing. They are all trapped on their islands, just like us. Maybe there are millions of civilizations in the Milky Way, but the average distance between civilizations could be 1,000 or 2,000 light years. If not even light can exchange messages in a timely way, if matter cannot travel without disintegrating over time, then each civilization is a candle lit in a dark and infinite room. We can see the glow of other candles if we use powerful telescopes, but we can never go to them. We can never feel their warmth. Space is not a connector. Space is an insulator. I understand the pain of this realization. Believe me, I wish it were different too. There is a child inside each of us who grew up looking at the sky, dreaming of the Enterprise, of the Millennium Falcon, of the idea that the final frontier was open to us. I would love to wake up tomorrow and see the news that we discovered warp drive. I would give anything to see, with my own eyes, the triple sunset of Alpha Centauri, or the theoretical oceans of TRAPPIST-1. The desire to explore is etched into our DNA, but we inhabit a finite body, governed by relentless physical laws. And here lies the great tragedy of the human condition. Evolution gave us the intelligence to understand the stars, but physics did not give us the ability to reach them. It is a cruel irony. We are capable of calculating the exact distance, chemical composition, and age of worlds we will never touch. We are prisoners who can see the landscape through the bars, draw maps of the world outside, but do not possess the key to the cell. And the hardest part to accept: the universe does not care. Gravity does not hate us. The speed of light is not a punishment. Entropy is not evil. They are just indifferent. The universe is a vast, cold, silent machine that functioned for 13.8 billion years without us, and will continue to function long after we are gone. It owes us no escape from this solar system. It owes us no habitable planets. It owes us no answers. This cosmic indifference is frightening, yes, but it is also liberating. The news of Voyager reaching one light day should not only fill us with expansionist pride, it should fill us with terrifying humility. It is physical proof that we are local creatures. We evolved on Earth, for Earth, and apparently we will remain on Earth. The idea that we can destroy this planet and simply move to another in another solar system is the most dangerous lie ever told. It is an escape fantasy that allows us to neglect our only real home. There is no interstellar plan B. There is no warp drive coming to save us. There is no federation of planets waiting for our call. There is only the vacuum, the cold, the radiation, and distances so vast that they turn our greatest rockets into static toys. A light year is a prison, and we are condemned to live and die inside this cell. So the next time you look at the stars, do not see them as destinations. See them as paintings on the ceiling of an unreachable cathedral. They are beautiful, they inspire us, but we will never touch them. Voyager 1 will continue traveling. In 40,000 years, it will pass close, on a cosmic scale, to another star. But the Earth that launched it will have changed beyond recognition. Its creators will be dust. It will be just a small metal coffin, carrying a golden record with sounds from a ghost world, wandering eternally through the silence between the islands of light.